Hello everyone, my name is Sainath. I am from CSMC section. Now I am explaining about principles and applications of NMR and IR spectroscopy. Unlocking molecular secrets, IR and NMR spectroscopy. The electromagnetic spectrum, our analytical toolkit. The electromagnetic spectrum is fundamental basis for both IR and NMR spectroscopy. These techniques harness different regions of the EM spectroscopy to interact with molecules, providing unique insights into their structure and properties. From radio waves to gamma rays, each region of the spectrum interacts with matter in distinct ways, allowing us to problem molecular characteristics. IR spectroscopy utilizes the while NMR spectroscopy employs the radio waves. IR spectroscopy, the dance of molecules vibrational modes. Infraradiated spectroscopy relies on the principle that molecules observe specific frequencies of infraradiated radiation that correspond to their unique vibrational modes. These vibrations can be stretching, change in bond length, or bending, change in bond length. Stretching vibrations. Symmetric and asymmetric stretching of bonds requiring energy input. Bending vibrations. Wagging, rocking, scissoring, and twisting motions of molecular groups. Resonance. When higher radiation frequency matches molecular vibrational frequency, energy is absorbed. IR spectroscopy applications. IR spectroscopy is used to identify the functional groups and impurities. IR spectroscopy is a powerful tool for qualitative identifying functional groups present in a molecule. Each functional group observes IR radiation at characteristic frequency, creating a unique fingerprint collection. For example, C double one O and O single one H N single one H. Functional group identification. Characteristic observation bands helps pinpoint to presence of specific groups. Purity assessment. Presence of unexpected peaks can indicate impurities in a sample. Reaction monitoring observes the disappearance of reactive peaks and appearance of the product peaks. Now we are explaining about NMR spectroscopy. NMR spectroscopy is the propagating the atomic nucleus. Nuclear NMR spectroscopy is known as nuclear magnetic resonance spectroscopy. NMR spectroscopy is non-destructive analytic techniques that provides detailed information about structure, dynamic reaction, and state chemical environment molecules. It specially detects if specific atomic nuclei that possess a spin property, most commonly 1H and 13. The sample is placed in the strong magnetic field. Then radio frequency pulses are applied, exciting the nuclei. The nuclei absorbs energy and then return their emitting signals. These signals are detected, converted into an NMR. NMR spectroscopy is known as special shift, chemical shift and spin-spin coupling explained. The power of NMR lies two phenomena, chemical shift and spin-spin coupling. This provides invaluable data for executing molecular structures. One is chemical shift and another one is spin-spin coupling. Now we will discussing about chemical shift. Chemical shift, the position of signal in an NMR spectrum measured in a parts per million ppm is known as chemical shift. It is influenced by the electron density around the nucleus, which in turn depends on the neighboring atoms and functional groups. Spin-spin coupling. The splitting of NMR signals into multiple peaks multiplicity is due to spin-spin coupling between non-equivalent neighboring nuclei. This spin-spin splitting patterns involve the number of equivalent protons on adjacent carbon atoms. NMR spectroscopy is applied on structure elucidation of organic molecules. NMR spectroscopy is indivisible in organic chemical for determining the complete structure of unknown compounds. By interpreting chemical shifts, coupling pattern and integration relative number of protons, a comprehensive structural picture can be built. One is proton NMR in 1H NMR, and second one is carbon 13 NMR, 13C NMR. Third one is 2D NMR technique. First one, proton NMR, 1H NMR identify the different types of protons and their connectivity within the molecule. Carbon 13 NMR reveals the number of types of carbon atoms and their chemical environments. 2D environment techniques is known as advanced technique like COSY and HMQC provide through bond through space corrections for complexity structure. Comparative between IR and NMR and strengths and also the limitations of NMR and IR. Both IR and NMR spectroscopy are powerful analytic techniques, but they offer complementary information and their distinct strengths and limitations. IR spectroscopy, there are some strengths like excellent for rapid functional group identification, relatively inexpensive and easy to operate, applicable to wide range of samples, solids, liquids, gases. And NMR strengths are the provides high detailed structural information. It can be determined connectivity, stereochemistry, and conformation data, non-destructive and qualitative. And infrared spectroscopy limitations are known as provided limited structural detail beyond functional groups, often ambiguous for complex mixtures, cannot differentiate between isomers easily. Limitation requires relatively large sample size and pure sample. Instrumentation is complex and expensive, longer acquisitive times compared. Advanced applications behind basic structure of determination. Behind their fundamental role in the structural education, IR and NMR find the diverse advanced application across various scientific disciplines. Reaction monitoring, protein and biomolecular studies, forensic analysis. Reacting monitoring. Track a chemical reactions in situ, observe intermediate formation and determination of reaction kinetics. Protein and biomolecular studies. Investigate the 3D structure dynamics and interactions of protein and nucleides. Forensic analysis. Identification of unknown substitution trace evidence in forensic analysis. Keywords and future directions in spectroscopy analysis. IR and NMR spectroscopy remains cornerstones of chemical analysis, continually evolving with new technological advancements. One is the complementary techniques, and the second one is the increasing automation. Third one is the enhanced sensitivity, and fourth one is the multidisciplinary impact. Best used complementary techniques is used in the together for comprehensive understanding of molecular structure. And increasing automation is used in the automation and manipulation of or making the techniques more accessible. Enhanced sensitivity. Ongoing research is improving the sensitivity and resolution of both IR and NMR. Multidisciplinary impact are applied and continue to expand across chemistry, biology, and